Okay, welcome all of you to another session. So now we are going to talk about design of sieverts. So in the earlier session we discussed about how to find out dry weather flow and wet weather flow. So dry weather flow estimation is so simple and so easy. It is population into per capita water demand into factor, and wet weather flow estimated by equation air by 360. This is a rational formula. So in this again I is equal to A1 I1 plus A2 I2. Finding I itself is a popular question in competitive exam. AN IN by total area, and R is estimated by using equation 25.4A by TC plus B. So TC is time of concentration, which is time of entry, time of flow, and A and B values depends on T value. For T 5 minutes to 20 minutes, we take A value 30, B value 10. For T greater than 20 minutes, we take A value 40 and B value 20. Usually this T generally you don't find, T is taken as equal to TC. Then from there we find out. This is what we discussed in morning session. And combined system we designed for combined discharge. Combined discharge is equal to Q dry weather flow plus Q wet weather flow. This is what we discussed. So now to accommodate this dry weather flow and wet weather flow in the sieverts, sieverts supposed to have a proper capacity. That's what's called, you need to design the sieverts to accommodate this flow properly. Sewage should not overflow. If sewage overflows, then what happens? All of the roads are flooded with the sewage because sieverts are so laid along the roads. So when roads are flooded with the sewage, then that in turn cause outbreak of diseases in the community. Therefore, to prevent outbreak of diseases in the community, so see that sewage flow inside the sewer only. So there should not be any flooding. So there sewers supposed to have sufficient capacity to accommodate dry weather flow, wet weather flow, and sometimes both of them together also. Depends what type of system we provide. Combined system we provide to accommodate both dry weather flow and wet weather flow. Separate system we provide one sewer we design for dry weather flow, other sewer we design for wet weather flow. So estimation of dry weather flow, wet weather flow is important. Then based on that we design the system, sewerage system. So let us see the design principles of sewers. So some noise is there, noise is coming, background, outside noise. Take it as a background music and adjust, okay? Ours is numericals only. Hope it is not disturbing you. Any disturbance is there, you type there. Any background noise audible to you? Some songs are playing outside. Ayappa Swami songs, they are playing Ayappa Swami songs. Loudspeaker, we can't do anything. Songs are playing outside. Hope those songs are not disturbing you, right? Okay, let us see. So sieverts normally, generally they are designed as open channels. So normally water supply pipes, by pumping we carry and convey water. But whereas sewage is not conveyed by pumping. There is no pumping of sewage. Therefore, we try to carry and convey sewage in a sewer by using gravitational force. That means self-weight. So sewers are designed as gravity conduits. So sewage in a sewer flow by gravity. Sewage in a sewer flow by gravity. Therefore, sewers are designed as gravity conduits. like our canals. How canals are designed, same way sieverts also designed. Canals also gravity system, isn't it? Sieverts are designed as gravity conduits. So design of siever means what? Design of siever include okay. Sieverts are designed as gravity conduits. Design of siever include two things. One is fixing one section of siever. Section of siever means cross section of siever. Second one is slope of siever. This is section of siever means what? Size of siever, otherwise. Section of siever and gradient of siever. Gradient means slope of siever. That is slope of siever. So to find out these two unknowns, we require two equations. So therefore, using those two equations, by solving them, we can design the sieverts. So to find the above two, it requires two equations. So normally sieverts are designed as gravity conduits. Though we use closed conduits, sieverts are treated as open channels. Since sieverts are treated as open channels, although we use gravity conduits, though closed conduits are used. Therefore, all formulae used in the design of open channels, they can also be used in the design of sieverts. So therefore, all the formulae used in the design of open channels can also be used in the design of sieverts. That is the advantage of treating them as open channels. Can also be used in the design of sieverts. So I need only two formulae. So one formula is, I can use continuity equation. One is I use, so therefore Manning's formula coupled with the flow continuity equation is used in the design of sieverts. So Manning's formula coupled with the continuity equation are used in the design of sieverts in finding the above two unknowns. So one is size of the siever, the other one is slope of the siever. What is one? Manning's formula, what is it? 1 by n r power 2 by 3 s power half, where in this equation n is equal to Manning's rugosity constant, or simply Manning's constant. And r is equal to hydraulic mean radius, which is equal to A by P. What is A by P? Wetted area by wetted perimeter. Then S is equal to slope of hydraulic gradient line. Actually it is slope of hydraulic gradient line, which is nothing but slope of seaward. Okay. So for in case of open channel, slope of hydraulic gradient line is parallel to bed slope of that open channel system. Therefore, slope of hydraulic gradient line is taken as slope of seaward. That's it. This is one equation which you can use in the design of seawards. Manning's formula. This is coupled with the continuity equation. What is that? Q is equal to area into velocity. So area into 1 by n r power 2 by 3 s power half. This is equation 2. So using these two equations, by solving these two equations, you can find out size of the seaward and slope of the seaward required. That's all. That is what is called design. By solving 1 and 2, so size of seaward you can find out, and slope of seaward you can find out. That's it. Nothing will be there. So simple and so easy. Design of seawards, so easy topic. Okay. So, but before we find out this, you need to know something about seawards. So normally, to find the circular cross sections are used in case of seawards compared to other geometric sections, because circular cross sections are hydraulically more efficient. And before that, and if you see this equation, V also, velocity of flow also unknown. So we try to figure it out, we try to find it out. So V is equal to velocity of flow in the seaward. I wrote no here. So V is equal to what? Velocity of flow. Flow velocity. So flow velocity in seaward. This flow velocity in seaward should not be too high, should not be too low. In any open channel, open channels like canals, they are designed for non-scouring, non-silting condition. Similarly, seawards also designed in the same way. Okay? So flow velocity in seaward should not be too high, should not be too low. Should not be too low and should not be too high. So it is kept anywhere between self-cleansing velocity to non-scouring velocity. I am introducing one new term here, self-cleansing velocity. Self-cleansing velocity means on its own seaward has to clean. It has to generate such a flow velocity such that it should not allow any particle to settle down inside the seaward. It is kept anywhere between self-cleansing velocity to non-scouring velocity. Okay? We need to keep flow velocity between self-cleansing to non-scouring. It should not be more than non-scouring, it should not be less than self-cleansing. If it is more than non-scouring, scouring of the seaward occur. If it is less than self-cleansing, what happens? Okay. More than self-cleansing, and it should be less than non-scoring. So the self-cleansing velocity is lower limit of flow velocity, non-scoring velocity is upper limit of flow velocity. So if I draw two lines here, one is representing something like this. So one is upper boundary, other one is lower boundary. Assuming like that, so my flow velocity in the sewer should not be more than that. Upper limit should not be less than lower limit. This is upper limit. The upper limit is non-scoring, and lower limit is self-cleansing. This is upper limit of flow velocity. This is lower limit of flow velocity. So flow velocity in the sewer should not be. This is flow velocity. We need to keep anywhere between these two, so that safely we can carry sewage. So let us see what is that self-cleansing velocity. That itself is a very popular question in competitive exam. Finding self-cleansing velocity itself is a popular thing. I'll repeat once again for latecomers. So once we find out dry weather flow, wet weather flow, the sewer has to carry this dry weather flow and wet weather flow to the treatment plant. There we treat, and after treatment we dispose that sewage again by using a sewer. So sewer plays an important role. So this sewer has to accommodate the dry weather flow and wet weather flow. Sometimes a sewer which is designed to accommodate both dry weather flow, wet weather flow. Sometimes dry weather flow accommodated in one sewer, wet weather flow accommodated in another sewer. Whatever it may be. Combined system is combined sewer has to accommodate both dry weather flow, wet weather flow together. Separate system, dry weather flow is taken care by one sewer, wet weather flow taken care by another sewer. Okay? Okay, so when sewer carrying this dry weather flow, wet weather flow inside it, it should not overflow. Therefore, we need to provide proper space inside. That's called size. Proper size of the sewer we need to provide. Then sewers are designed as gravity conduits. We don't pump sewage. Sewage contains so many number of things. It contains paper, it contains cloth, it contains wooden pieces, it contains cork, it contains glass bottles. It contains plastic bottles, so pumping is not possible by using regular centrifugal pumps. Specially designed pumps we have to employ, they are very expensive. Therefore 99.99% we avoid pumping. There is no pumping of sewage, no way we pump sewage. Understood? So sewage is generally conveyed by gravity, 99.99% we convey by gravity. So in case of gravity conduit, two things are very important. One is gradient. See now, you assume that this is a sewer, so this is sewage. Assume that this pen is a sewage. So when you keep this pen on a flat surface, what happens? It doesn't move, isn't it? You want to move this pen over this cell phone. What you need to do? Provides proper gradient. Little slightly inclination you provide, then it will move. So sewage has to move inside the sewer, just like this. So when it moves like this, what happens? it generates sufficient flow velocity and safely we can take out whichever point we like. Understood now? Hope it is clear to you. Okay? So they are designed as gravity conduits. So two things, design means only finding two things. One is proper size is required, proper slope we need to provide. So that's what I discussed. And to find out these two, slope and size, right, we require two equations. So generally we use closed conduits, but yet we treat sieverts as open channels because of prevailing same hydraulic conditions. Whatever hydraulic conditions prevail in open channels, same hydraulic conditions prevail inside the siever also. Therefore, we don't have any difficulty in treating sieverts as open channels. Though we use closed conduits, yet we treat them as open channels. The advantage of treating them as open channels is, so whatever design concepts are there in the design of open channels, all those design concepts we can use in the design of sieverts as well. Okay? All those formulae which we use in the design of canals, we can also be used in the design of sieverts also. Because we don't have any special design concepts to design the sieverts. So we follow open channel design concepts. Okay? So to find out two unknowns, we require two equations. One equation is Manning's formula we use. The other equation is continuity equation. So continuity equation, Manning's formula. That's what I wrote here. So Manning's formula is equal to V is equal to 1 by N R power 2 by 3 S power half, and continuity equation is Q is equal to area into velocity. So where in that equation N is equal to Manning's constant, V is equal to velocity of flow, R is equal to hydraulic mean radius, which is equal to wetted area by wetted perimeter, S is equal to slope of hydraulic gradient line. In case of open channel, slope of hydraulic gradient line is parallel to bed slope of the open channel, therefore it is taken as slope of siever. So size of siever, slope of siever, by solving these two equations we can find out. That's what we discussed. Then very important component that is to be provided in the design of siever is flow velocity. With what speed you need to drain sewage inside the siever. What speed sewage has to flow inside the siever, that is very, very important. So that in any open channel, velocity of flow is very, very important. So we need to provide flow velocity in such a way that it should not scour the canal bed. At the same time, it should not allow any particle to settle down inside the canal. The same way in the siever also, we also designed for the same concept. So sievers are designed for no scouring, no silting condition. That no scouring condition is called, by no scouring happens when flow velocity is less than non-scouring velocity. No silting happens. Silting means settling. No settling of particles occur inside the siever when it maintains flow velocity slightly more than self-cleansing velocity. Therefore, we need to maintain flow velocity anywhere between self-cleansing to non-scouring. Understood now? This is what I covered. Clear? Triple R, triple K. Dr. Israr. Clear, Mr. Doctor? Okay then, let us see what is that self-cleansing velocity. Triple R, are you from ACE Academy? Syllabus completed for you? So it is called V self-cleansing. So actually it's a revision class. So much detailing not required for you. Already you know all these things. Okay. Self-cleansing velocity means what? It is a minimum velocity at which no silting, no settling of particles occur. So minimum velocity at which no settling of particles occur in siever. This is called self-cleansing velocity. We work it out by using equation. Oh, Ankit Kumar, so many joined today. 3 people are taking class. This is the highest strength I got so far in Unacademy. So highest number of people watching my session is 3. So I am utter flop in Unacademy, I think. V self-cleansing is equal to, it is 8K by F into S minus 1 into G into D under root. So using this equation you can find out self-cleansing velocity. So self-cleansing velocity itself is a very popular question in competitive exam. Just finding self-cleansing velocity. Okay, let me explain what is these parameters in this equation. So this K is known as sediment factor or particle factor. Sediment is nothing but a large sized particle. When large sized particle, the flow velocity could pull, small particles automatically it can pull. Large sized particle. We aim to pull large sized particles by generating sufficient flow velocity. If large particle is pulled, small particles automatically pulled. Understood? In case of sedimentation tank design, what we do? If small particles settle down, large particles automatically settle down. Exactly opposite to sedimentation is, it has to flow. So when it happens flow, when large particle flow, small particles automatically flow. When large particles flow under the influence of velocity, small particles automatically flow because they don't offer much resistance. Large particle offer more resistance to flow. Therefore, large particle could flow along with the sewage under the influence of flow velocity. Small particles automatically flow. Right? Exactly. In sedimentation, small particles offer more resistance to settle down. Large particles easily settle down. Small particles difficult to settle down. Therefore, if we could settle down small particle, large particle automatically settle down. Whereas, in draining the particles, to see that particle move along with flow, when large particle flow along with the sewage, small particles automatically flow along with sewage because large particle offer more resistance to flow compared to small particle. That is the concept. Understood? So that sediment is nothing but a large sized particle, and sediment factor is K is nothing but sediment factor. Right? And F is known as friction factor. And S is equal to specific gravity of sediment. And D is equal to size of the sediment. Normally we assume that is spherical particles, so it is diameter of sediment, diameter of particle. So it is diameter of particle, which we aim to pull along with the sewage flow. So it is actually derived. This derivation is there in irrigation engineering textbook. If you see in irrigation engineering textbook, you will find how you can what is that flow velocity which will prevent the settling of particles inside the irrigation channel. Okay, canal, like canal. That's all. So we can work out. Normally, if you work out large size particles, sewage self-cleansing velocity should be anywhere between 0.6 to 0.9 meters per second. Not slightly more also, but we have to work out it. Randomly you can't take like this. Similarly, non-scoring velocity. Non-scoring velocity is the maximum velocity at which no scouring of sewer occur. Maximum velocity at which no scouring occur in sewer. No scouring of sewer occur. So this depends on. So this is given by IS code. So normally we use two types of sewers. Sewers are made up of some material. So non-scouring velocity recommended by Government of India. This is for IS code. Okay. By experimentation they found this. So it depends on what kind of material we use in sewer manufacturing or sewer making. So strong material you use, more velocity can provide. Lesser strength material you use, the less flow velocity you attract. Generally we use cement concrete sieverts or RCC sieverts. CC means cement concrete siever, RCC means reinforced cement concrete sieverts. So for them we need to maintain anywhere between 2.5 to 3 meters per second non-scoring velocity, not more than 3. If it is above 3, scoring happens. And second one is cast iron siever. CI stands for cast iron. CC means cement concrete. So cement concrete sieverts, reinforced cement concrete sieverts. You have civil engineers only, no, you are all. CI means cast iron sievers. So normally cast iron is used, cement concrete. Cement concrete sievers, cast iron sievers are popular. So for cast iron siever, cast iron stronger it is. So therefore you can go up to 4.5 meters per second also. This is given by IS code. This is as per IS code. So you have to keep this flow velocity inside the siever anywhere between self-cleansing to non-scouring. Okay. That's one thing you need to keep in your mind. Then second thing is the size of the siever or section of the siever. Section of the siever means size of the siever. So normally circular sections are recommended to other geometric sections. Circular geometric sections preferred to other geometric sections, because circular sections are hydraulically rectangular, trapezoidal and all we don't use in case of sievers. Geometric sections. Okay. Circular sections are more efficient. Circular sections are hydraulically more efficient. Therefore we recommend them. Therefore size of siever means what? Size or section of siever means what? Size of siever means it is diameter of the siever. That's what you need to find out. So whenever we talk about size of siever, by default it is diameter of siever, because we use circular siever. Circular sections are hydraulically more efficient. That is one thing. And one more thing is the flow condition inside the siever. That is also very, very important, because that wetted area, wetted perimeter are there. Flow condition in siever. Sievers always run with partial flow condition. That means partially they carry sewage. That is, there is some empty space inside the siever. Because of that empty space, finding that wetted area, wetted perimeter become very, very difficult. That it become little complex to find out that wetted area, wetted perimeter. If it flow full, it is running full, siever is full cross section is occupied by the flow. It's so simple to find out wetted area, wetted perimeter, because wetted area is equal to pi by 4 d square, wetted perimeter is equal to pi d. But sievers never flow with full flow condition. Sievers always run with partial flow conditions. Okay? Because of that, this finding out that wetted area, wetted perimeter becomes slightly difficult. Sievers always run with sievers always flow with partially full conditions. That is partial flow condition. They carry partially full. Sievers always run with partial flow condition. Otherwise, I'll better word. Run means what? Carry sewage inside. Partial flow condition. Partially full only. Partially full. Never flow with full condition. Partially full. That is, there is an empty space in the siever. Empty space kept in the siever. This empty space is to take care of flow fluctuations. Okay? To take care of flow fluctuations, even if you produce more flow than what expected, still there is some space. Therefore, there is no overflow of sewage. There is an empty space kept inside the siever, inside siever. What purpose? To absorb flow variations. Okay? To absorb unexpected, unforeseen flows while serving the public. So at any cost we don't allow overflow of sewage from the sewer for that condition. Inside sewer. Because of this empty space, sewage, then sewer design become slightly difficult, slightly complex. So the sewers are designed for following flow conditions. I'll just will carry out some analysis. Case 1. Sewer running full. This is easiest among all cases. Sewer running full. That means complete cross section is occupied by flow. That is D is equal to D. Here D means depth of flow. Depth of flow in sewer. And capital D is diameter of sewer. Diameter of sewer is equal to capital D. Sewer running full. That means it is carrying full flow. So something like this. Sewer is running full. Assume this is a sewer, circular section. So it is completely carrying flow. So flow is occupied, complete occupied. So this is easiest among all cases. This is only depth of flow. This is only diameter. So in this case, wetted area is equal to, it is pi by 4 d square. Wetted perimeter is equal to pi d. Hydraulic mean radius is equal to A by P. We will get d by 4. Then velocity of flow is equal to 1 by n r power 2 by 3 s power half. So from this you can find out 1 by n, sorry, 1 by n and d power to the power 2 by 3 s power half. This is equation 1. Equation 2 is q is equal to area into velocity. Area is again wetted area only, pi by 4 d square into 1 by n d by 4 2 by 3 s power half. This is equation 2. By solving 1 and 2, we will get diameter of the sewer and slope of the sewer. That's it. It is so simple and so easy. Right? By solving 1 and 2, we get diameter of the sewer and slope of the sewer. So simple and so easy, the easiest among all cases. But you can't expect a question from this case, usually. GATE exam. GATE exam, little complex questions. One more popular case is sewer running half full. Case 2 is sewer running half full. Half full condition. And half portion is empty and half portion is occupied by sewage. That is D is equal to D by 2. Depth of flow in the sewer is equal to half of the diameter. So in this case, so this is sewer. This is sewer. It is running half full only. Okay. So flow is there only half of this portion. This is sewage flow. Remaining half is empty. This is only occupied. So this is your D. This is your D and this is your diameter of the sewer. Understood? So in this case, wetted area is equal to what? Wetted area. It is pi by 8 d square, not pi by 4 d square. Half full only it is. Wetted perimeter is equal to, it is pi d by 2. Hydraulic mean radius is equal to A by P, which is equal to pi by 8 d square by pi d by 2. If we simplify, you will get d by 4 only again. So velocity of flow is equal to 1 by n r power 2 by 3 into s power half. So it is 1 by n d by 4 to the power 2 by 3 into s power half. See now, Shiva running full, Shiva running half full, flow velocities are same. The advantage of second case is you got some empty space. This empty space I can accommodate extra flow also. But empty space is not there here. Little extra flow generated in a community, then Shiva overflow because there is no space to accommodate. It is flowing tightly occupied. There is no empty space. But here advantage is empty space. Understood? So still flow velocity is same. Both of them flow with same velocity. If Shiva of given diameter, Shiva of given diameter d, given slope yes. When Shiva running full, Shiva running half full, flow velocities are same, identical. But discharge is not same. Because the reason being, so Shiva running full is area into velocity. It is pi by 8 d square. Shiva running full, pi by 4 d square. Shiva running half full, it is pi by 8 d square. So though flow velocities are same, but discharges are not same. So by solving 1 and 2, we can find out diameter of the Shiva and slope of the Shiva. That's all. This is also a very popular question in GATE exam and other competitive exams. Shiva running half full, because most of the people they take pi by 4 d square, but that is not correct. It is pi by 8 d square you have to take. Clear? Somebody comment there. The concept, am I confusing you or any confusion is there? Okay. Then this is also popular. Then one more popular thing is Shiva running more than half full, Shiva running less than half full. This much is not required. In EE course, case 3 and 4, case 3, Shiva running less than half full. Shiva running less than half full means what? That is d is less than d by 2. That's the meaning. So if we take a Shiva, okay, let us assume it as a Shiva, circular Shiva, less than half full. So exactly, assume that this is half. So Shiva running less than half full. This is a flow. Okay. So this is depth of flow. D. This is d by 2. And this is another d by 2. So total diameter is d. So in this case it becomes slightly difficult. So what we do is we try to find out angle subtended by the free liquid surface. We try to find out angle subtended by free liquid surface with center O. Let us assume this angle is 2 theta. Then this becomes theta. So the theta is found, you can work out. Then wetted area, this in open channel flow, your search might have taught you. Then wetted area is equal to, it is r square into theta minus sine to theta by 2. And wetted perimeter is equal to, it is 2r theta. Hydraulic mean radius is equal to a by p. So it is r by 2 theta into theta minus sine to theta by 2. So you can find out this. 2r theta. Where r is equal to radius, right? This radius, this is r is equal to this radius. So otherwise you can take diameter. 2r is equal to diameter. So theta into d. Or d into theta otherwise. That way also you can work out. 2r is d. d into theta also you can take. Okay? This theta I have to find out. Then rest of them automatically you will get. Then velocity of flow is equal to 1 by n r power 2 by 3 s power half. This is equation 1. And q is equal to area into velocity. So area into 1 by n r power 2 by 3 s power half. This is equation 2. So by solving 1 and 2 you will get slope of the sewer and diameter of the sewer. Okay? But here theta is very important. This theta is making an angle like this here. So this is r, and what is this value? This value also, this is d. This value is d by 2 minus d. So this become d by 2 minus d. This is theta. Then cos theta is equal to, it is d by 2 minus d by r is equal to d by 2 no. Radius is d by 2 only. So it is d by 2. So theta is equal to what? Cos inverse d by 2 minus d by 2. That's how we can find out the theta value. Understood? So finding theta is important. Velocity of flow same in all cases. Yes. Velocity of flow we fix. We don't change velocity of flow. So remaining things will change. Yes, in all cases velocity of flow is same. So case 4. Case 3 and case 4 are little complex, but we have got easy procedure, don't worry. We don't find thetas and all. So we have got ready-made procedure for that. But first learn basics. So sewer running more than half full. Same way we can evaluate, that is d is greater than d by 2. Depth of flow is greater than half of the diameter. Okay? So let us take this is sewer running more than half full. So let us assume so this is your d, diameter of the sewer. This is d by 2 and this is another d by 2. So depth of flow is more than this one. This is our depth of flow, more than half full. Same concept we can use. Angle subtended by free liquid surface with center. I'll take this as center O. Now angle has changed. Now this has become 2 theta from here to here. Then what is theta? This is your theta. This is 2 theta, no? Then this is your theta. And to find out the theta, you have to find out alpha. Same equations you can use. So wetted area is equal to r square into theta minus sine to theta by 2, and wetted perimeter is equal to 2r theta or d into theta, and hydraulic mean radius is equal to a by p. It is r by 2 theta, right? R by 2 theta, yes. R by 2 theta into theta minus sine to theta by 2. Then using equation v is equal to 1 by n r power 2 by 3 s power half. This is equation 1, and q is equal to area into velocity. So area into 1 by n r power 2 by 3 into s power half. So by solving 1 and 2 you can find out diameter of the sewer and slope of the sewer. That is the procedure. But finding theta also difficult here. See now you got alpha, one more angle here. This is alpha and this is our theta. So this value is, this is our depth of flow. Depth of flow is this. Depth of flow is more than diameter. This is depth of flow, and this value is this value. Only this value is d minus d by 2. This value is d minus d by 2, and this value is r, which is equal to d by 2. This triangle I am talking. This is alpha. This alpha I have to work out. From here to here, alpha it is. So this is alpha. So cos alpha is equal to cos inverse d minus d by 2 by d by 2. Once you get alpha, then theta is equal to 180 minus alpha. So once you get theta, rest of them formula substitution. But this and all not required. Case 3, case 4 don't follow this. So to find out, note. So sieverts running more than half full or less than half full. We use partial flow diagrams. More than half full condition or less than half full condition. Partial flow diagrams or partial flow tables are ready-made diagrams are available, ready-made tables are available to find out that wetted area, wetted perimeter, hydraulic mean radius and all, velocity of flow straight away, or discharge also. Half full condition, partial flow diagrams or partial flow tables are used. Partial flow tables are table is used to find out hydraulic flow parameters. Of course, basis is that only, but to make our life simple and easy, they have developed them. Hydraulic flow parameters. So, the table, the chart you see is called partial flow diagram. This partial flow diagram is given to you. So it is a d by d ratio will be given here. Here they will give small v by capital V, small q, okay. Discharge, area, velocity, all those things. For every parameter is a function of d by d. So small q by capital Q, small v by capital V, small a by capital A, like that, etc. For every parameter there is one curve will be given like this. Discharge curve, velocity curve, area curve, like that. Discharge curve, velocity curve, area curve. So if you know d by d value, then remaining you can pick up. Suppose discharge you want to find out. D by d value is known to you, right? From here you can interpret q by q, how much discharge curve. Similarly velocity curve, from velocity curve you can interpret v by v. Similarly area curve a by a. Like that straight away you can find out. This is also difficult for some civil engineers to make their life still easy. So they have given these values for d by d. So q by q values. This is called partial flow table. V by V, A by A, like this. For every parameter they have developed like this. So d by d is 0.1, d by d is 0.2, like this up to 0.9. Values will be given 0.9 and 0.92 also. That much accuracy. So knowing what d by d values, suppose d by d values some 0.3 is there. So against d by d 0.3, I will read q by q value, v by v value. Okay? Some x is there, some y is there. Then if I know for full flow condition, discharge and velocities, I can find it for partial flow condition. So small q, small v, small a represent hydraulic flow parameters for partial flow conditions. Capital Q, capital Q, capital Q, capital V, capital A represent hydraulic flow parameters for full flow condition. Working out for full flow is so simple and so easy. Therefore, for full flow condition, knowing the things for full flow, we try to arrive at partial flow condition. Okay? In this equation, small q, small v, small a, etc. represent hydraulic flow parameters for partial flow conditions. Discharge, velocity, wetted area, etc. Similarly, capital Q, capital V, capital V, etc. represent hydraulic flow parameters for full flow conditions. If you know for full flow, partial flow, automatically you can pick up from those table or diagram for partial flow, full flow condition. That's all. This is what we use This is what you need to learn. This is what is expected in EE course. This question is asked. Understood? Come on, comment there. How many of you got clarity regarding this? Velocity, anything you can fix up. It could be anything. It should be there anywhere between self-cleansing to non-scouring, that's all. Shall we take up questions now? Yes, they will give you a table in the exam. If at all they ask. If you are expected to find out from the table, they will give you a table. You are expected to find out from the diagram, they will give you a diagram. You need not worry. Okay? That's why if we solve few varieties of questions, we will be comfortable. Shall we take up questions now? Anil Ankit Kumar? Maybe North Indian students, they are not attending my class because I am not speaking in Hindi, because I am not good at Hindi. My Hindi is very poor. If I start speaking in Hindi, you will run away from my class. You will make fun of me also. So nowadays YouTube is very popular, Unacademy is very popular teaching in Hindi. So I am not that good in Hindi. But मैं भी कोशिश करूँगा थोड़ा बहुत बोलने के लिए इन हिंदी में. I'll try. Okay, let us solve some examples, some questions. So through numericals we get more clarity, right? This question is been asked in GATE 91. This question has been asked in GATE 91 exam. GATE 91 means obviously you might have not born at my time. A 20 centimeter diameter sewer is laid at a slope of 0.004 and designed to carry a discharge at a depth of 10 centimeter with a Manning's N. Manning is the name of a person. With Manning's N is equal to 0.014. The design discharge is, how much discharge it is carrying is asking. Dash liters per second. Come on, work out. Diameter of sewer is 20 centimeter. But it is carrying flow discharge at 10 centimeter only. That means the depth of flow is 10 centimeter. Easy question only. So diameter of sewer is given as 20 centimeter. Depth of flow is given as 10 centimeter. That is sewer running half full. D is equal to D by 2. That is sewer running half full. Half full condition easy only. This is important first of all. You supposed to have this idea. Sewer running half full, indirectly given. So see, we're running half full. What is wetted area? It is pi by 8 d square. So it is pi by 8 into 0.2 square. 0.2 meters. I converted into meters. Right? Hydraulic mean radius is equal to A by P. So which is equal to d by 4 only. It is 0.2 by 4. Now we can straight away substitute in the equation. Q is equal to area into velocity. It is pi by 8 d square into 1 by n into d by 4 to the power 2 by 3 into s power half. So slope is given. S is given as 0.004. Come on, now substitute. How much amount of discharge it carry? So pi by 8 into 0.2 square into 1 by 0.014 into 0.2 by 4 to the power 2 by 3. S is 0.004 to the power half. Come on, simplify. We will get answer in meter cube per second. Then later you can convert into liters per second. Calculate. So I am getting 9.6 into 10 power minus 3 meter cube per second. So which is nothing but 9.6 liters per second. So that was the answer for this question. Verify. Don't take it for granted, you verify the answer. Yes. So now let us take one more question. So with varieties of examples, you can learn better and better. So design the section of a section means what? Diameter. Combined circular sieve for full flow. She mentioned for full flow. From the data given below, she has given data. Population of the locality, $50,000. Area to be served, 150 hectares. Maximum velocity, maximum permissible velocity. That means what? Non-scoring is given. That means so you are not allowed to provide velocity of flow more than 3.2. So you can provide 3.2 meters per second. Time of entry, 5 minutes is given. Time of flow, 20 minutes. rate of water supply. All this data is given. So this is continuation to the morning first session. Dry weather flow, wet weather flow estimation we made, no? So that also you need to work out on your own. 270 LPCD. Okay? Impermeability factor. What is that impermeability factor? I value is 0.45. Assume 75% water supply convert into sewage. Come on, work out now. What is this factor? So what you need to do is dry weather flow, wet weather flow to find out. So discharge is equal to dry weather flow plus wet weather flow, combined discharge, that is. For that you need to find out diameter of the sewer. Come on, for that discharge you need to find out diameter. Come on, work out, try all of you. So, first of all we need to find out dry weather flow. Q dry weather flow is equal to population into per capita water supply into factor. What is this factor? Fraction of water supply converted into sewage. So population is given as 50,000. Per capita water supply is given as 270 LPCD, and fraction of this is converted into this one, 75%. 75% means this is taken as 0.75 factor. So factor is taken as 0.75. This is liters per day. To convert this into liters per day into meter cube per second, by 1000, by 24, by 60, by 60. Then it becomes meter cube per second. Come on, work out how much it is. So 50,000 into 270 into 0.75 by 1000 to 24 into 60 into 60. This is 0.117 meter cube per second. Q wet weather flow is equal to air by 360. So in this A is given, I is given, R is not given. Instead of giving R is given time of entry, time of flow. So therefore we can calculate time of concentration. Time of concentration is equal to time of entry plus time of flow. So this time of entry is given as 5 minutes, time of flow is 20 minutes. So it is 5 plus 20, 25 minutes. So T is not given as usual. So whenever T is not given duration of storm, therefore T is taken as equal to time of concentration. So which is equal to 25 minutes. So T greater than 25 minutes, 20 minutes. Therefore A is taken as 40, B is taken as 20. Therefore R is equal to 25.4 A by TC plus B. So 25.4 into A is 40, TC also, time of concentration 25 plus B is 20. So straight away will get answer in mm per hour. Come on, work out R value. So 25.4 into 40 divided by, so it is 22.57 mm per hour. So I can find out wet weather flow. So wet weather flow is equal to air by 360. Area is given 150 hectares. Should be in hectares. I is unitless. I value is given in the question as 0.45. This is I. Impermeability factor. This is I value. 0.45. R value just now we arrived. 22.57 by 360. So 150 into 0.45 into 22.57 by 360. So 4.23 meter cube per second. So therefore combined sewer is designed for combined discharge. Since it is combined sewer designed for Q combined. So this Q combined is equal to, it is Q dry weather flow plus Q wet weather flow. So dry weather flow we got 0.117 plus 4.23. Come on, how much it is? You have to work out. Not myself. I don't write any exam. You will write exam ultimately. It is 4.348. It's almost 4.35. Okay, 4.348 meter cube per second. Okay, therefore Q is equal to area into velocity. See, we are running full. You have been asked to design for full flow condition. Therefore, see, we are running full. When sewer is running full, wetted area is equal to pi by 4 d square and hydraulic mean radius is equal to d by 4. That's all. So Q is equal to Q combined, which is equal to area into velocity, so which is equal to pi by 4 d square into 1 by n r power 2 by 3 into s power half. So you have to find out diameter of the sieve, right? Design the section means diameter you have to find out. So remaining things are there. So this is 4.348 is equal to pi by 8 d square into n value given no in the question. Manning's rugosity constant is not given. He has to give no n value. Oh, not required all these things, sorry. This formula also not required. Velocity of flow is given already. Oh, this is also not required. Slope is and all not required because velocity of flow is given. That is given as 3.2 meters per second. Given a maximum permissible velocity. In the question only given 3.2 meters per second. So into 3.2. So diameter of the sieve is equal to come on, how much it is? See now 4.348 into 8 by pi into 3.2. So it is 1.86 meter. I got diameter of sieve as 1.86 meter. You verify kindly. Don't take my answer granted. I got 1 point. Somewhere, anywhere I went wrong. Am I right? This is 4.35. Okay, rounded, no issue. That is not a big issue. Oh, see, we're running full now. See now, I am going wrong. 5 by 4 d square this is. Why I 8 d square I put? You are not correcting me. Why? Why sir, you are not correcting me? 4.348 into 4 this is. Not 8. Purposefully I wrote wrong to cross check whether you are taking class seriously or not. So 1.315 meters. That is the answer. Understood, sir? You mentioned, you mentioned? Okay, very good. Very good, Israr. Good. Ankit also mentioned. Very good. Let us try one more question. Different questions is all, you become familiar with this concept. Example. This is a little lengthy question, but this much length they don't ask, only portion. Just to give practice to you. So this is question number, example number 3. Try all of you. Find the minimum velocity and gradient required. Before that, okay. Okay. Find minimum velocity and gradient required. Gradient means slope. Minimum velocity means what? Self-cleansing velocity, indirectly asking. To transport sewage with sand particles of 1 mm diameter. The sand particles are sediment now. So it is carrying sand particles of 1 mm diameter. So the sand should not settle down inside the sewer. So sand is taken as sediment. And specific gravity is 2.65. Through a sewer of 1 meter diameter. So diameter of the sewer is given. Assume, not assume, take, okay. Assume K is equal to 0.1, F is equal to, not assume, take, sediment factor, take, K is equal to 0.1, F is equal to 0.03, and sewer running half full. And N is equal to 0.013. Come on, work out all of you. Try this question. Let me see whether you manage this question or not. So here sediment is sand particle. She has given sediment property, nothing but sand, and sewer property is also mentioned here. So you have been asked to find out self-cleansing velocity, and second thing is that slope of the sewer. To maintain that self-cleansing velocity, what should be the slope we need to provide? So diameter of the sediment is given as 1 mm. You can convert into meters. Okay. Specific gravity is 2.65. K also sediment factor 0.1. F is a friction factor 0.03. And sewer dimensions are given as diameter of sewer is 1 meter, running half full. Therefore R is equal to D by 4. So running half full. Since it is running half full, okay, then what else is given? N. Manning's N is given as 0.013. This is sewer properties. Okay, can't work out self-cleansing velocity formula I gave you using that. So V self-cleansing is equal to, it is 8K by F into S minus 1 into GD under root. Okay, substitute in this formula, you will get that. So 8 into K is given as 0.1, F is 0.03, S is 2.65 minus 1, G is 9.81 meter per second square. D is diameter of the sediment, 1 into 10 power minus 3. under root. Simplify, we will get that. Straight away will get answer in meters per second. So I got 0.657. So 0.65 meters per second. 6569, almost 657. Okay. Then to maintain this velocity, what should be the slope we need to provide? So 1 by n, r power 2 by 3, s power half. So 0.65 is equal to 1 by 0.013. Given now this is into r is d by 4. D is given. D by 4 is equal to 1 by 4. So 1 by 4 to the power 2 by 3. S is unknown. Find out slope. Come on, work out. Solve this equation, find out slope. Yeah, 0.6569. 69 means 7 almost. Similarly, find slope. So it is 0.25 to the power 2 by 3 by 0.013 inverse 1 by x into 0.65. Okay, square of this one. So slope is equal to 0.00045. I got this as 0.00045. You can keep like this, or otherwise you take inverse of this value. You can also mention like this, 1 by 2205.66, or you can write 1 in 2205.66. Anyway you can express. All are 1 and same. Whatever you get, you take, okay? I calculated per 0.65. If you take 0.656, slightly answer will be different. No issue. Concept you have to learn. Yeah, 4631, okay, it is, no issue. Let us try one more question. Example 4. We try to solve different kind of questions so that you become familiar. Okay, this is also GATE question. Calculate the diameter of a circular sieve. He has given n value in brackets. Of course, vitrified clay sieve something is mentioned, that means n value is given, which will just carry 0.05 qmax. Qmax means meter cube per second. When flowing full at a slope of 1 in 1000. Okay, this first question. If the second question is, if the flow were at a 0.6 depth, okay, what would be the discharge and velocity in partially full sewer? What would be the discharge and velocity in partially full sewer? And he has given table, given the following data. I mean, he has given partial flow table. So d by d, q by q, v by v values are given to you. Okay. So he has given for 0.1, 0.5, 0.6, 0.8. Within this only one value you have to choose. So for this he has given 0.02, 0.39, 0.54, 0.85. V by V values 0.3, 0.8, 0.88, then 0.01. Come on, work out, try this question. So table is given. This is called partial flow table. From this table you can pick up straight away. You need not find out theta, alpha, this and all not required. You need not use area is equal to r square into theta by sin theta, that and all not required. Completed? Did you complete? Oh, you got answer. Very good. Nice. First question is so simple. Sewer running full. Sewer running full. What should be the diameter of the sewer? That was the question. When sewer running full, diameter of the sewer. So Q is given as 0.05 meter cube per second. N is given as 0.013 in the question only. Then slope is given 1 in 1000. 1 in 1000 means 1 by 1000. Therefore, Q is equal to area into velocity. I will take capital A, pi by 4 d square into 1 by n, r power 2 by 3, s power half. Since running full, half full, r is equal to d by 4. So, I can write this. So, Q is 0.05, it is pi by 4 d square to 1 by 0.013 into d by 4 to the power 2 by 3 into s power half, 1 in 1000 to the power half. Find out the diameter. Correct you are? So diameter of the sewer D is equal to, it is 0.36 meter. Very good. Mr. Ankit Kumar, you are wrong. 0.027 you got, it is wrong. 0.36 is right. Okay. Second part is so simple and so easy. So he has given depth of flow. Depth of flow in the sewer, that is D. Small d is given as 0.6 times diameter. Therefore, d by d, if you work out how much it is, 0.6 d by d, it is 0.6. So from the table given in the question, from partial flow table, given in the question, so at d by d is equal to 0.6. At d by d is equal to 0.6, what is v by v? At d by d 0.6, q by q is 0.54, v by v is 0.88. At d by d is equal to 0.6, q by q is equal to 0.54, and v by v is equal to point how much? 0.88. That's all. Therefore, discharge when it is running at full partial flow condition is q. Therefore, q is equal to 0.54 times capital Q. Capital Q is running full. Already this is given in the question, 0.05. Okay, discharge you gave. Okay, good, good. 0.027 meter cube per second. This is discharge running in partial flow condition. Similarly, velocity of flow. So V is equal to 0.88 times V capital V. Capital V is running full. So running full we know 1 by n, d by 4 to the power 2 by 3 and s power half. So 0.88 times running full. So 0.013. D already we got just now, we got 0.36 by 4 to the power 2 by 3. S is 1 in 1000 to the power half. This all will get that. Come on, velocity of flow find out. So 0.36 by 4 to the power 2/3 into root 1 by 1000 by 0.013 into 0.88. So I got 0.429 meters per second. That is velocity of flow. So three questions, three things have been expected to calculate. First one is this one. Second one is discharge and velocity of flow. So three things. Clear now? Very good. Let us try one more question. With that we'll wind up. I hope it is clear to you now. Example 5. This is also GATE question. But here he has given diagram is given. Instead of table, diagram is given. GATE 2004. An existing. Of course, he has given diagram. I can't plot that diagram, partial flow diagram. Approximately, I'll give values, okay? An existing 300 mm diameter circular sewer is laid at a slope of 1:280. That means 1 in 280 has given 1:280 and carries a peak discharge of 1728 meter cube per day. Use the partial flow diagram in the figure below. He has given this and assume n is equal to 0.015. Then what I have been asked to find out is at the peak discharge the depth of flow and velocity are respectively respective. And he has given diagram, partial flow diagram. I can't plot exactly, but I'll help you in giving values to you. So he has given here d by d, here q by q, v by v. So two curves are given there. One is discharge curve, the other one is velocity curve, like this. Okay, let us see how to work out this problem. Values and all I will mention you at the time of solving the question. First part, I think what you need to work out, what idea should be there. Last question, d by d is given. In this question, you have been asked to find out what depth of flow. Depth of flow means what? Small d. Then, what is second question? Depth of flow and velocity of flow, small v. Depth of flow and velocity of flow. So, how to find out small d, this small v. So, capital Q, small q are indirectly given in the question. So, what is given in the question is small q is given. When it is carrying peak discharge means it doesn't mean that it is carrying full discharge. So when it is carrying Q, what is depth of flow is asking. That means it is partially flowing. Okay? And what is velocity of flow is asking when it is carrying this. So capital Q you can find out. Capital Q is running full. What is capital Q? Sewer running full. When sewer running full, discharge in the sewer is, wetted area is pi by 4 d square and r is equal to d by 4. Therefore straight away you can find out Q is equal to area into velocity is pi by 4 d square into 1 by n r power 2 by 3 into s power half. Right? But what is given? Slope is given 1 in 280. He has given in the question, and what else is given? N value is given 0.015. Okay? Diameter is given. Diameter of the sewer is given as 300 mm, so which is equal to 0.3 meters. Then you can substitute and find out. So pi by 4 into 0.3 whole square by 1 by 0.015 into r is d by 4, 0.3 by 4 into 2/3, and s is 1 in 280 to the power of. You can find out when sewer running full, what is the discharge it carry. Come on, work out. So it is pi by 4. So I got 0.05 meter cube per second. This is. So 0.05 meter cube per second, but this is given in meter cube per day. Let me convert this also in meter cube per day. So which is equal to 0.05 into 1 second is equal to 1 by 24 into 60 into 60 days. That will go to numerator. Meter cube per day. So how much it is? Into 24 into 60 into 60. So it is 4,328 approximately meter cube per day. So I got this much. So now using this, you can find out small q by capital Q ratio. So from this you can find out small q by capital Q ratio. Small q is given as 1728 by 4328. Approximately you can work out. So 1728 by 4328. So it is approximately 0.4. Because you have to read from the curve. So from the curve what you need to do is at q by q 0.4. This is q by q axis. Exactly at 0.4. You draw one vertical line on discharge curve. One discharge curve is there. Like this discharge curve is there. Draw one vertical from here. At exactly q by q 0.4, draw one vertical which intercept the discharge curve at one point. From there drop one horizontal line which intercept to d by d axis. This is d by d axis. So because the table is not given, values are not given to you exactly at exactly approximately 0.4, it is approximately coinciding with 0.5. So therefore at q by q is equal to 0.4 from partial flow diagram. D by d is equal to 0.5. Therefore depth of flow is equal to 0.5 times diameter. So 0.5 times 300 mm or 0.5 times 0.3 meters. Okay, 300 mm you can take. So it is 150 mm. Options are given. That option is matching. So depth of flow D is equal to 150 mm. Then similarly, velocity curve also there. So from the velocity curve, this velocity curve also given like this. So at d by d 0.5, again you drop one horizontal line. From here you drop one horizontal line which intercept velocity curve. From there drop one vertical which intercept this axis. This will give v by v value. How much it is? This v by v also there in this axis. So actually that curve I have not plotted there. So this value v by v value, from there I can read approximately at 0.5 it is coming 0.8. So at d by d is equal to 0.5. d by d is 0.5, v by v is equal to 0.8. Therefore velocity of flow is equal to 0.8 times v. So 0.8 times 1 by n d by 4 to the power 2 by 3 into s power half. So already we know how to work out for full flow. 0.015 into d is 0.3 by 4 to the power 2 by 3. S is 1 in 1000, no? 1 in 280, sorry. 1 in 280. Come on, this will be the velocity of flow. Straight away you get meters per second. So it is 0.3 by 4 to the power 2 by 3. It is 0.566 meters per second. But answer given is 0.57. So I can write 0.57 meters per second also. So he has given 0.57 meters per second. Options are given. So that is how we can work out. Of course, table is not there with you, you cannot get it. But anyway, take it for granted, table is there with me. I can't plot it here, right? Point 399 exactly, I can't read from that graph given there. So approximated to 0.4 it is. Okay? 4320 you got, okay, no issue. I can correct it, no problem. You got 4320? No problem, because I'm an old man, so maybe I'm wrong. Okay then. Happy, huh? Is that? So the answer is 0.57 meters per second. So this is how we design the sewers. Hope it is clear to you. So my time is also over. So tomorrow I'll start characteristics of wastewater. There we discuss about BOD problems. Very, very important for GATE exam. Right? Do attend all of you. I request you attend all of you. Bring your friends also if possible. At least this will help them. So tomorrow I'll be dealing with So tomorrow I'll take class from 4 o'clock to 6 o'clock and again 8 o'clock to 10 o'clock. 2 sessions I'm planning to take. 4 p.m. to 6 p.m. first session. There I'll talk about BOD and COD problems. BOD problems and COD numericals. Okay. Then again I'll take 8 p.m. to 10 p.m. second session. There we talk about treatment, sewage treatment. Treatment of wastewater otherwise. Treatment of wastewater. So these two topics also important. BOD, COD. So tomorrow also very important class. So do attend tomorrow. Don't miss the classes. Bring your friends, as many as possible. See that I am also successful in Unacademy platform. So your friends groups are there. Do recommend. Bring your friends also along with you. I request you. Anyway, it's a free channel only it is. So you can watch. This is. In addition to that, some promotional content is there. So they are offering this mock examination free of cost. So enroll all of you. And if you want for more details, you can contact that number displayed there. 8585858585. Yeah, I'm planning to take geotechnical engineering as soon as I complete this. I'll take geotechnical engineering because these two subjects are very, very important to get good rank in the exam. Geotechnical engineering and hydrology also I'll take. Before you write exam, I'll try to complete these three subjects. Or if time permits, I'll take transportation also. Okay then, good night all of you. Again we'll meet tomorrow. So tomorrow I'll be taking two sessions. So 4 p.m. to 4 p.m. to 6 p.m. first session. There we talk about BOD and COD. Then 8 p.m. to 10 p.m. second session. There we talk about sewage treatment. Both of them are very, very important topics for GATE exam point of view. Do attend all of you. Thank you. Thank you. Good night.